Cyberstrak has released a new version of its Rhino plugin, version 1.5, which is now available for download. Hi folks, I'm Gigi, and in this video I will show you what's new in this plugin, including new features and bug fixes. So, let's get started. With the plugin version 1.4, if you would choose the Rhino Dark appearance, then in some dialogues the text strings would be displayed in black, which made them hard to read. This is now fixed in version 1.5. With this release, you have a new window available called Cyberstrak Options. In this window, you can control the display of the geometry when being used in Cyberstrak commands or when being displayed by the Cyberstrak display. So let's have a more detailed look into each of these sections and how they work. Let's start a Cyberstrak mesh command, in this case the split mesh. Once you're inside the tool, you are asked to select a mesh, and once you did, you're in a sub-selection where you're asked to click on the mesh to select the sub-region which you want to split out. While you're in this selection, which is a Rhino selection, you can't press cancel or OK. So once you're happy with the area of the selected mesh, you press the right mouse button, and then this selection is confirmed, and you can either add or reduce the area if you're not 100% happy. But once you are happy, you can press OK and you're back in the main tool. And as you can see here, the selected mesh area and the base mesh have a very similar color. The Cyberstrak Options window allows you to change the color of the base mesh. So let's go, for example, for a more contrasting shading color, like in this case, gold. And now you get a very nice contrast, and you can better distinguish between the selected mesh area you currently have and the base mesh. In a similar way, you can change the boundary color, for example, to red. You can also control how the net is displayed, so activating the net here, and let's go for maybe dark gray. And you can control the color of the vertices as well, so let's change them to, for example, black. Yep, and these are basically their color options. On top of that, you have the transparency slider, which allows you to increase the transparency of the base mesh in case you need to have some background geometry or information you need to see better. This is the place where you can change the transparency of the mesh. The next section in the Cyberstrak Options window is controlling the Cyberstrak Zebra display. When in any Cyberstrak function, for example, like the surface blend, you can activate the Cyberstrak Zebra display by going to the Cyberstrak dockbar and activating the Zebra analysis option. And the display of this zebra can be controlled, for example, by switching from horizontal to vertical. You can change the stripes thickness, and by the way, the default of this option is taken from the Rhino Zebra command, so any setting you've done there is taken over here as the default. And you can also change the color of your stripes to any color you'd like. The last option in this window is controlling which environment is taken for the diagnostic surface reflection option in the Cyberstrak dockbar. So if you're activating the Cyberstrak display and activating the diagnostic surface reflection option, you'll see that an environment is taken and used as a reflection image to reflect on the geometry. If you want a, for example, less busy environment to be able to judge the surface transitions in a better and more calm way, you can change the environment file to something, for example, the Gem Studio, and have a nice reflection analysis available to you. Always remember, this one uses the existing mesh tessellation, so if you're, for example, not happy with the surface resolution here, go to the Rhino document properties, to the mesh section, and just increase the amount of polygons, and you should see a better quality of the reflection on the surfaces. When the Cyberstrak display is active, the option Show Individual Materials is now also working when the geometry is receiving its material via layer assignment. This wasn't the case in version 1.4. On top of that, the option UV Orientation shows now also the normals of the input surfaces as well as the geometry to be created. The new Cyberstrak version now supports better working with trimmed surface edges like in this scenario here. One example of this is that the transition analysis supports measuring against such edges, but also the matching tool itself allows you now to match against such edges. You see a new option here, partial, which has been activated automatically. The function has recognized that the edge to be matched against is much longer than your initial edge, so it has activated this option. If you hit apply, the matching is only happen on a partial basis, measuring the closest distance from your edge to match to the reference. If you don't want this, you can deactivate the option, of course, and you would match to the whole edge instead. But also you can, like in this example, if you want the partial matching to happen only on one side, you have handles here. So you can, while keeping the partial matching on one side, you can move the handle up to the end of the edge on the other side if this is what you want. The support of trimmed surface edges has also been improved with the surface blend function. Before, this tool would always blend only natural untrimmed surface edges, or in case the surface was trimmed, would take the underlying untrimmed edge, while it's now capable of handling the trimmed edges instead. If you still see shortened edges you don't expect, like this one here, be aware that a trimmed surface edge can consist of multiple spans. In a scenario like this, you want to use the merge edge function of Rhino and make this one edge again, and then the surface blend tool just works as expected. This trimmed edge, this edge here is shortened, but it's still a natural surface edge, right? In this case, the whole continuity options like tangent and curvature are available. If you have an edge like this, which does not follow the natural surface edges around, this tool works also, but in this scenario it would only allow you to match positionless result on these edges, so you are not capable of activating tangent or curvature. Sometimes when you have sections of a certain distance, you don't want them to start from the center of your coordinate system, but instead where a certain surface or feature starts. The new option Delta Origin allows you exactly that. You can select the point with the Rhino Snap options, and then the sections start at this point and are calculated to both directions with the data from that exact point. The Cyberstrak matching function can now also match inside into a surface. To do so, when you're calling the matching tool and have selected the edge to match, you need to cancel the selection by pressing the right mouse button, because that selection is looking for a curve or an edge. And now you press on the surface button inside of the dialog and select the surface you want to match into. If you then hit apply, you can see we achieve position continuity, but you can also go for tangent, and now you can see that the zebras start to line up, or curvature continuity. Now with this matching, because the surface has a limited amount of CVs, we've now broken an existing matching quality to the next surface here. If you want to keep those and want to allow the matching tool to increase the CVs to keep such alignments, you can activate the option opposite side, hit apply, and now you can see we're preserving tangency. And you can also go for curvature on the other side, and the function will maintain that continuity as well. Usually when measuring the deviation between two objects, the first option in the deviation dialog reads the number of graphs and controls the amount of graphs being calculated to measure the deviation. However, when both of the objects are meshes, the number of graphs option doesn't make much sense, and instead you can see that it changes to fractional points instead. When this option is set to 1, then it means that every point on one mesh is being used and projected onto the other to measure the deviation. If you're changing the option to 2, then only every second point is taken, and every third, fourth, or fifth, and so on. This allows you to make the analysis more lightweight and by that more performant, which can be important if you're trying to get two pieces of a scanned object together again, and then you need the analysis to be performant, and therefore you can use this option then. By the way, information like this, which isn't like straightforward, remember that you can always click on the question mark to bring up the online help of the Cyberstrak plugin, and there you can find then more in-depth information on the options and what they do. That's it with the summary of the Cyberstrak Release 1.5. I hope you found this video useful, and see you in the next one.